Hi, everybody. So the purpose of this video is to go over the practice test that is meant to help you prepare for the lab test that you have next class. So in class, you received an actual physical paper copy of this review sheet. The key is posted in my Google Classroom, but I thought it might also be worth just making a short video where I actually go through the answers for those of you who want a little bit more explanation. And as always, if you are preparing for the lab test and you have questions, you don't understand maybe why an answer is the way it is, please ask me because this review sheet is shockingly similar to the lab test that you are going to receive your next class day, all right? The one big difference on this particular review sheet, we gave you the graph. On the lab test, you need to make the graph. We are going to give you data. We are going to give you graph paper. We're going to give you a ruler, and you have to create the graph exactly like what you did when you did the density lab, okay? So just know that I think is really honestly the big change. There might be other little things here and there, but it's the same. So if you can sit down and do this entire review sheet confidently and feel good about it, then you are in a very good spot going into that lab test, okay? And since you're watching this video, that means you want to prepare for it, so yay for you. So the first question says, what does the slope of the line represent? So don't just tell me what is slope, okay? What does it represent? Well, in this lab, it represents density, all right? I've had people in the past say the slope of the line represents the change in y over the change in x. That's what the slope actually is. It's not what it represents. So it represents density, the average density of the class data, if we want to be really specific. Number 2 says, calculate the slope of the line. Now to do this, you need to plot 2 points on the actual graph, like what we actually did. So I am going to plot a point. Let's see. I want to find a spot maybe right here. Looks kind of good. And the coordinates for that would be 2.0, comma, what is that? Each of those on the y, each of those is 2, so that would be 14.0. And I'm going to just take it to the tens place. All right. And then I'm going to plot another point. Let's see, what's a good spot here? What did I do? This one's good. Okay, so on here, 4, 8, each of these goes up by 0.4. So that would be 6.8, comma, 48.0, I believe. Again, if your points are different than mine, that's perfectly okay. I just found 2 points where the diagonal crossed the hash marks of the graph paper. Yours may look different. That is okay. So as always, when you are doing a calculation, you want to start with formula, right? So slope is going to be equal to the change in y over the change in x. Now, there are other slope formulas out there, but this is the one that we are using for this lab. So slope, I cannot type this morning, goodness gracious. All right, slope is going to be equal to, get our division line going on. See, change in y, so that would be 48.0 minus 14.0 in the numerator, and 6.8 minus 2.0 in the denominator. So I do want to make sure that you show your substitution, okay? So if I actually do that subtraction real quick, remember just the rules of rounding. I took these to the tenths place, which is probably a safe place to go to. So when I subtract, I want to keep it to the tenths place. I think actually in the lab test, it might even specify where to take that to. And then let's see, 6.8 minus 2.0 is going to be 4.8. There we go. So my slope, do not leave it as a fraction, okay? Do not leave it as a fraction. Actually solve for slope. And your unit here would be grams per milliliter. The reason for that is if you were to actually go in and put units on things, your Y's are actually milliliters, right? What I'm doing there we go. And your X's are actually grams. So it ends up, I did that backwards. My apologies. That's grams, that's grams, that's milliliters, that's milliliters. There we go. Now we're cooking. All right, so I would wind up with grams over milliliters is where that unit really is coming from. Now in the substitution for this one, you can, because we're using coordinates, you can just put the numbers, that's okay. But make sure that you have a final answer. All right, and then it is super helpful just to help me with grading. If you put a box or circle your final answer, especially if stuff starts going all over the place, that can be super helpful. Letter B says the actual density is blah. Calculate the percent error. Okay, I will tell you on the lab test, I'm not going to specifically tell you the density is blah. Okay, what I'm going to do is give you a little chart that has 4 different metals with their 4 different accepted densities, and you need to compare the density that you found, that's what this is, to the chart to figure out, and you're going to make a judgment. I think this metal is iron. I think this metal is titanium from the 4 options that are given to you. So make sure you actually write that down. I remember last year, a lot of people lost points on this particular question because they never actually told me which metal they thought it was. They just dove right into a percent error problem. So make sure you say, I think the metal is cadmium, and then do your percent error. So read carefully, all right? Make sure you're actually answering all parts of the question. So my formula for percent error is going to be equal to, draw my division line here. And I am going to abbreviate a little bit. Measured value minus accepted value divided by accepted value. Now, if you wind up with a negative number in your numerator, you do want to take the absolute value of that, okay? And you're going to multiply this whole thing by 100. All right. So then my substitution percent error is equal to, my measured value is what I actually calculated. So 7.1 grams per milliliter minus the accepted value, which they're telling us is 7.3 grams per milliliter. Okay, so I'm going to take the absolute value of that. I'm going to divide it by the accepted value, 7.3 grams per milliliter, and I'm going to multiply the entire thing by 100. Okay. So if I go through and actually do that, I'm going to wind up with a percent error of 2.7%. Probably worth actually labeling. Percent error is 2.7%. And then it is always helpful to put a box or a circle around your final answer. Okay. So that's it. Observing a chemical reaction. It says, give an example of a quantitative observation, give an example of a qualitative observation. So here's what's going to happen on the lab test with this one. You are going to have a short little blurb about an experiment where they're going to tell you what the student saw. You then need to, from that blurb, tell me what is quantitative, what is qualitative. So a quantitative observation, quantitative, think quantity, is anything with a number attached. So for example, mass, volume, temperature, what else do you measure that has a number on it? Pressure. So if you are taking a measurement, length, width, height, any of those, water displacement, that is going to be a quantitative observation. Okay. Qualitative, think quality, is anything without a number. So color, odor, shape, bubbling. I don't know, those sound great. So anything that when you are recording data about it, there's no number attached, okay? Give an example of an interpretation. So you need to know the difference between an interpretation and an observation. So if you are not remembering that, maybe go back and read the background, to this lab, observing a chemical reaction. So an example of an interpretation would be, in this reaction, comma, I think the aluminum foil rusted. Do I know that it rusted? No, because in fact it didn't. It underwent what's known as a single replacement reaction. But an example of an interpretation is anytime you can start the sentence with, I think that. It's not an observation. Observations would be the aluminum foil changed color. The solution got hot. Those are observations. Those are things you are actually experiencing with your senses. An interpretation is, what do you think happened? Okay. So what is the difference between a physical change and a chemical change, a chemical reaction? All right. In a physical change, it does not change the composition. So you still have the same stuff. Water freezes to ice. It's still H2O. That is a physical change. This piece of paper, still paper, physical change. It didn't become a different substance, okay? A chemical change then does change composition. So you are literally making something new. We went from aluminum to aluminum chloride. That was a chemical reaction. So how do you know that a chemical change occurred when you added the aluminum foil to the copper 2 chloride solution? A bunch of different reasons. We could say gas was produced. That's usually a good indicator. Solid changed color. If you notice, the solid went from being aluminum foil, shiny, high luster, silverish color, to being red and kind of crumbly. And the other one, change in temperature. Anytime there is a change in temperature, that is a really good indicator that there is a chemical reaction happening, okay? And then lastly, we're going to ask you some questions about a flame test. What does it mean to say that an electron is in the ground state? It means the electron is in the lowest possible energy level. I'm going to add in here closest to the nucleus. So it's as close to the nucleus as it can be. Remembering, though, that those energy levels can only hold a certain amount of electrons, right? The first energy level, the one closest to the nucleus, can hold 2. The second energy level can hold 8. The third energy level can hold 18. So if you had 50 electrons, you fill the first energy level first, then the second, then the third, and so on and so forth, okay? Based on that 2n squared rule. Number 9, how does an electron reach an excited state? By absorbing energy and moving to a higher energy level further from the nucleus. So you have your ground state atom. It absorbs energy, whether it's electrical energy or thermal energy, and the electrons are going to jump away from the nucleus to a higher energy level, and now they are excited. But tying into the next question, when they are excited, it is extremely unstable. They cannot stay there. So as soon as they can, those excited electrons are going to fall back to their ground state. When they do that, they shoot out light. And that light, all kind of ties in here, is unique for every single element. So as we look to question 10, it says, how did Bohr explain the bright line seen in the line spectrum of hydrogen? Light was emitted as electrons moved from high to low energy levels. So we'll say returned to ground state. Okay. Number 11, could you identify an element by using the flame test? Explain. So, kind of. If it's just the flame test, so you are looking at it with your naked eye, you will have an idea of how much energy the atom as a whole is going to have. And we know certain elements glow certain colors in a flame test. Like copper has that very distinctive green color. So if you see that green flame test, then you probably know it's copper. The better way, though, is to take that light and put it through a prism and get the bright line spectra. And that's where I'm going to take this answer. I'm going to say each element has its own unique bright line spectrum. So put the emitted light through a prism to see its spectrum. Okay? Something along those lines. All right, guys, so that is everything that's on this review sheet, and that is everything that's going to be on the lab test. The questions might be worded slightly differently, but all of the content and concepts that we just talked about, that is what the test is going to be on. Again, the test is your next lab day, so next time I see you, please bring a non-graphing calculator, okay? You will be provided with reference tables, graph paper, a ruler. I would recommend bringing a pencil. This is going to actually be on physical paper, okay? You have the entire period, but it didn't take us that long to do the review sheet. The only thing that it might take you a little bit longer is that you actually have to make the graph, and it counts as a lab grade, okay? I think that's everything. If you do have questions or you want to just talk through something, send me an email and we can do that, okay? See you soon. Bye.